Hi, my name is Talia, and I'm a high school student who loves teaching others chemistry and math. This YouTube channel is a supplemental resource to anyone who may be having difficulty in their chemistry classes. This week, I'm going to be talking about molar mass and mole conversions, so if you need help with those topics, feel free to keep on watching, and without further ado, let's get started. Okay, so for this video, you are definitely going to want your periodic table as well as your calculator. I'm going to first start by explaining what molar mass is. Molar mass is found on the periodic table under the element symbol. So for instance, if you look on your periodic table under the C in carbon, there will be 12.01, which is the molar mass. And the molar mass represents the mass of one element or compound in grams, and it is given in the units of grams per mole. Now, I said that molar mass can be found under the symbol on the periodic table. That is for when you're finding the molar mass of an element. Obviously, compounds are not on the periodic table, so to find the molar mass of a compound, you just take the molar masses of each of the elements in the compound multiplied by their respective subscripts, add them together, and that becomes the molar mass of the compound. So the first example with calculating the molar mass of a compound that I have is H2O. So I'm just going to go back through the steps that I just mentioned. I'm going to take the molar mass of each element in the compound, multiply it by its subscript, and add them all together. So first we have hydrogen. The molar mass of hydrogen under the H is 1.008. So I'm going to multiply that by 2. And then add 16, which is the molar mass of oxygen, and add it together to get 18.016 grams per mole. Now let's try BaCl2. So I'm going to look for Ba on the periodic table. Underneath it is the molar mass. My periodic table has 137.33. Yours might be slightly different, but you're going to get pretty much the same molar mass. And then we have Cl. So if you look under chlorine, there's a molar mass of 35.45. And I'm going to multiply that by 2 because there are 2 chlorines in BaCl2. And then I'm going to add that together and get 208.23 grams per mole. Okay, so next we have H2SO4. So I'm going to do the same thing. I have 2 times 1.008 plus 32.06 is the molar mass of sulfur, plus 4 times 16 is the molar mass of oxygen. I'm going to add that all up. I'm going to get 98.076 grams per mole. That is the molar mass of sulfuric acid. Next, we have F2. So this is a diatomic element like I talked about in the last video. So to find the molar mass, there are 2 fluorines. So I'm going to multiply 2 by 19 and get 38.00 grams per mole. That is how you calculate molar mass. And now I'm going to move on to mole conversions. So this kind of takes metric and non-metric conversions to a new level, converting between moles, mass, and number of particles. And number of particles can either be atoms or molecules. Okay, so I've divided this section up into 3 parts. We first have moles to mass, and you are going to use the molar mass to do that. Okay, so we have this first example of finding the mass of 2.9 moles of sodium. And we know the molar mass of sodium is 22.99 grams per mole, which we found on the periodic table. Now, 22.99 grams per mole is a fraction. It's 22.99 grams in each mole. So we can rewrite this as a conversion fraction like this. And that is going to be helpful when converting between moles to mass. So we know that with conversion fractions, we want the unit that we started with to cancel out. And that means it has to be on the denominator of our conversion fraction, usually, unless you have like a reciprocal. So we are going to go with this conversion fraction. And also you abbreviate moles in a conversion fraction or units by just writing MOL. So I'm going to write out 2.9 moles of sodium and then times 22.99 grams per mole. So now, as you can see, moles of sodium cancel out. And then we just multiply 2.9 by 22.99, and we get 67 grams sodium. because of sig figs. And we do not account for the sig figs in the molar mass because that is like a constant number. It's not what you're given in the problem. Okay, so I flipped this problem around so we can practice the conversion the other way. So this problem says, find the moles of 7.8 grams of MgO. So we first have to calculate the molar mass of magnesium oxide. So we have 24.30 plus 16.00, and that equals 40.3 grams per mole. So now we have two ways of writing the conversion fraction. We could write mole over 40.3 grams, or we can write 40.3 grams over a mole. So now we have to look at our givens to determine which fraction we're going to use. We have 7.8 grams, and we want to cancel out grams, so we know the grams has to be on the denominator of our conversion fraction. So we are going to use this one. So I'm going to multiply by 1 mole over 40.3 grams, and this means we are dividing. So I have 7.8 divided by 40.3, and I get 0.19 moles of magnesium oxide. So that is from moles to mass. So for moles to mass, you use molar mass because either grams or moles will cancel out based on what you're given, and you'll get the other unit. Now we're going to go from moles to particles, where you will use Avogadro's number. And that is that 1 mole is 6.02 times 10 to the 23rd atoms or molecules. So if we have 1 mole of MgO, that's 6.02 times 10 to the 23rd molecules. And this conversion fraction can be written in two ways, just like the molar mass one. We can have the Avogadro's number on the top or the bottom. And again, this depends on what we're already given. If we're given particles, we want Avogadro's number on the bottom so they can cancel out. And if we're given moles, we want moles on the bottom so moles can cancel out and we can get particles. Just a quick review, atoms are particles for substances with 1 atom. So if you have magnesium, it's an atom. However, molecules are particles for substances with more than 1 atom or element. So NaCl, that's 2 elements, and that can be classified as a molecule. So here I wrote that when you use Avogadro's number from units of moles, the moles aren't canceled out, because if you have like a mole over here, these will cancel out and you'll be left with just particles. So let's look at some example problems. I'm not going to do these. I'm just going to talk you through them. Let's say you have how many moles are in 5.6 times 10 to the 20 times 10 to the 30th molecules of CO2. So we are starting with molecules and we are trying to find moles. So we know that molecules need to cancel out. So I'm going to use the conversion fraction with molecules on the bottom. And when I have atoms or molecules over here, that is just like depending on the problem, that's what you would use. If you are given atoms, use atoms. If you're given molecules, use molecules. So here molecules will cancel out and we are left with just units of mole. That's just what I explained here. So molecules are in the denominator of the conversion fraction to cancel out units of molecules. And this would be written without the ES. Okay, so now we have the flip side. We have how many molecules are in 2.2 moles of NABR. So we are starting with moles and we want to get rid of moles. So we are going to use the other conversion fraction because moles will then cancel out. And then you just multiply 2.2 by 6.02 times 10 to the 23rd. And this is your answer. And I would also probably write NABR here. And so you just did opposite operations. In the first problem, you divide by Avogadro's number because it's on the denominator. And in the second one, you multiply because it's on the numerator. So like I said earlier, you would use the same conversion fraction to calculate atoms, but with units of atoms instead of molecules. And that depends on what you have / what you're trying to find in your problem. Continuing, we have mass to atoms or molecules. And this is a 2-part conversion because you use both molar mass and Avogadro's number. But you calculate moles first because Avogadro's number has units of moles. It's 6.02 times 10 to the 23rd atoms or molecules in a mole. So you need to get to units of moles first, and you do that by using the molar mass. So let's say we need to calculate the mass of 9.25 times 10 to the 23rd molecules of potassium bromide. So we first need to calculate moles. I'm going to do that by dividing by Avogadro's number, because we have molecules on the numerator here and the denominator here, and then we are given moles. And these moles can therefore be used with the molar mass, and the moles cancel out and we can get grams. So moles is kind of like the in-between stage in between mass and molecules. And also, if you're doing multiple calculations, keep the unrounded version in your calculator to use for further calculations. Okay, and our final mole conversion I'm going to talk about today is calculating the atoms of each element. So with this, you are going to use Avogadro's number and the amount of atoms of each element within a molecule. That'll make more sense once we try this example. So let's say we need to find how many molecules are contained in 0.650 grams of K3PO4. So that is a mass. Now we want to find how many atoms there are of each element. So first we need to find molecules. And we do that by getting to moles first. So we always, like I said earlier, if we're going from grams to molecules, we always need to get to moles first. So to calculate moles, we're going to use the molar mass, which I calculated here. And then just like any conversion, units of grams cancel out because grams are on the denominator, and we get these moles of K3PO4. Now we are going to calculate molecules. So we did this step. Now we're going to, and we are at moles currently. Now we need to calculate molecules. So I'm going to use Avogadro's number. Because we are trying to find molecules, we need to cancel out moles. So moles will be on the denominator. And here I divided by the molar mass. And then over here, I'm going to multiply by 6.02 times 10 to the 23rd, because it's on the numerator, to get 1.84 times 10 to the 21st molecules of K3PO4. So now we got molecules. So this was all previous conversions. Now I'm going to explain how to find the atoms of each element. So to do that, you are going to multiply by how many atoms there are of each element in the compound, and that will cancel out the units of molecules and get you to atoms. You do not have to multiply by Avogadro's number again, because that'll just get you back to moles. The only way to get from molecules to atoms is to have the units of molecules somewhere in that conversion fraction, and also have the units of atoms somewhere in that conversion fraction, because if you don't have both necessary units, you won't get to the correct answer. So if we start with 1.84 times 10 to the 21st molecules of K3PO4, and we first want to find the atoms of potassium. We know we have 3 atoms of potassium in 1 molecule of K3PO4, because there's a subscript 3 by the potassium. So I'm going to multiply this amount by 3, and I get 5.53 times 10 to the 21st atoms potassium. Then I do the same thing with phosphorus. I know there's only 1 atom of phosphorus because there's no subscript. So I multiply by 1 atom of phosphorus over 1 molecule of K3PO4. The units of molecule K3PO4 cancel out, and we are left with just atoms of phosphorus. Finally, we are doing oxygen. There are 4 oxygens, so I'm going to multiply the amount of molecules by 4 atoms of oxygen over 1 molecule K3PO4. Again, molecules K3PO4 cancel out. We multiply by 4 and get 7.37 times 10 to the 21st atoms of oxygen. And that is number of atoms of each element. So that is all of the basic mole conversions you'll be doing as you advance through like stoichiometry and stuff like that, which I'll explain in later videos. So you always want to make sure, just like with metric conversions and non-metric conversions, that the unit you already have is on the denominator of your conversion fraction, so it can cancel out and you can get to a new unit. So now we're going to do a practice problem where you're going to calculate the number of molecules in 54 grams of dinitrogen trioxide, and then also how many atoms are there of each element. So try this on your own, and then I'm going to go over the solution. So the first step I did with this was identify that dinitrogen trioxide is written as N2O3. It's a covalent compound, so I use the prefixes to determine the formula. Then I found the molar mass because that's key in getting from grams to moles, and we need to get to moles to figure out anything else. So I multiplied 2 times 14.01 plus 3 times 16. I found those numbers under the symbol in the periodic table to get the molar mass of dinitrogen trioxide. So first step, I needed to convert to molecules if I want to get to atoms. So I did 2 conversions in one. I first converted 54 grams to moles. You can do this in a separate conversion if you would like. I did it all in one. And the units of grams here will cancel out. I put grams on the bottom because you already have grams. So I divided by 76.02. And then here I am multiplying by Avogadro's number because I already have moles. So moles will cancel out. And all I have left are units of molecules. So if I divide by 76.02 and multiply by 6.02 times 10 to the 23rd, all the units cancel out, and I'm left with 4.3 times 10 to the 23rd molecules of N2O3. Okay, so now I'm going to utilize the number of atoms of each element in the molecule in order to create a conversion fraction and calculate the number of atoms of each element. So I know that there are 2 atoms of nitrogen in the molecule of N2O3 because it's dinitrogen trioxide. So I put that on the numerator because I want to get rid of the units of molecules, multiply this number by 2 to get 8.6 times 10 to the 23rd atoms of nitrogen. Now I'm going to do the same thing with oxygen, except there are 3 atoms of oxygen in one molecule of N2O3. So again, molecules of N2O3 cancel out, multiply by 3, and I get 1.3 times 10 to the 24th atoms of oxygen. So this kind of combined all the different conversion fractions I went over. So again, like I said earlier, it's all about canceling out. That is the main idea with conversions. You just want the units to make sense and cross out so you can get the unit that you are looking for. So always make sure you're putting the correct things on the numerator or the denominator in order to make sure you get the right answer. And that concludes this video. So I hope you enjoyed this week's video on molar mass and conversions. Next week, I'm going to be talking about hydrates. So if you need help with that topic, feel free to join me back again next week. I'm going to leave a link in the description box to my website where you can schedule tutoring if you would like. If you have any questions, feel free to leave them in the comments and I will do my best to answer them. I hope you enjoyed this video and good luck with learning the rest of your chemistry.